Today we will take a look for the microservice architecture styles or microservice pattern. This is one of the quite popular architectural style that is used nowadays. Specifically, it is quite popular since it was firstly published in 2014 by the Martin Fowler and James Lewis. They published in 2014 this approach, and microservices is generally inspired by ideas in domain-driven design, DDD, the logical design process for software projects. That concept of DDD means that we build our services around the domain. And when the developer defines a domain, that domain includes many entities and behaviors identified in artifacts such as code and database schema. Let's take a look for the topology first. Here is the topology of microservice architecture. The service size in microservice is much smaller than other distributed architectures that we already take a look before, such as a service-oriented architecture, for example. Each service to include all necessary parts to operate independently. So please pay attention for it. So it include all necessary parts to operate independently. So it should be independent instance that can be deployed separately, including database and other dependent components. So if we will compare, for example, with service-oriented architecture, we can notice that the database was shared between services. Here, each service should include independent database, independent storage. This is a general example how the topology can look like. It doesn't mean that microservice architecture should exactly looks in the same way. What I mean, for example, here you can see the communication through the asynchronous messaging. It can be any of implementations such as Kafka, RabbitMQ, or so on, but it can be, it cannot be. It can be here or different in the different places. You can notice that some services has like bigger number of instances. Nowadays, if we are talking about the Kubernetes, it is called like pods, where you can scale your application, and specifically that instances that is required to be scaled. Let's take what is the key points that we should pay attention when we take a look for the microservice architecture. First, it will be that it is distributed. What it means? A microservice from a distributed architecture. So each service runs on its own process, which originally implies a physical computer but quickly evolved to virtual machines and containers. Mostly nowadays, when we are talking about the separate running process, it means that everything should be wrapped by containers. And this is one of the significant difference if we will compare this architecture style with maybe not all others, but with some of others that can be, for example, run on container environment or on premise, for example, can be delivered. Here, everything should be wrapped by containers. Which kind of containers? Most of the popular nowadays is, I believe you already know, it is Docker. It's not just only one, but it one of the most popular containers nowadays. Decoupling the services to this degree allows for a simple solution to a common problem in architecture that heavily feature multi-tenant infrastructure for hosting applications. So yes, when you wrap your service into the container, you can run your container in different environments, and this is mostly related to the infrastructure issues. Separating each service into its own process solves all the problem brought by sharing. Performance is often the negative side effect of distributed nature of microservices. Please pay attention for this, because sometimes it can be noticing that, as I told you, microservice is quite popular architecture style, and nowadays a lot of companies, a lot of projects are built based on this approach. And some category of stakeholders, customers, they maybe not even customers, but the owners or that who are paying for the development, they expect that the system will be with high performance, and also it will be high scale and so on. But this is not about actually about microservices. If you would, and maybe you remember on the first one of the first presentation, we just take a look for the expectation that can be, that you can expect, but it will not work. It's not true, and this is one of the of them. So you shouldn't expect high performance between the microservices, because what? Because it is highly distributed. If it is highly distributed, then communication between services should be performed through they should be, first of all, there will be a lot of communication between them, and it will be implemented in the way, not like you are trying to call one of the methods from one class to another one, but this communication will be maybe synchronous by the REST API or asynchronous by messaging, and a lot of services will be involved in this process. So it means that the lag between this communication will be increased. So in general, it will influence to the performance. So because microservice is a distributed architecture, experienced architects advise against to use of transaction across service boundaries, making determined the granularity of service the key to success of this architecture. Yes, this is mostly, as for me, this is one of the most important points or sentences in general when we're talking about the microservice architecture, because you have to understand that when you choose the microservices, you not only lose or maybe lose in performance, but you can also lose on data consistency. If you will make the wrong division between services, if you will not the division, if you will make mistakes in the granularity of the services. So it means if you will divide the services in a wrong way, then it will influence a lot of communication between the services, and it means that, but the transaction can be implemented just only by the service. It's quite hard to implement the transaction cross the services, cross communication of the services. It is very hard, I will say. And so it means that in most of the cases, you will lose this transaction supports and the ACID operation through the communication of services. It means that if something will wrong in one of the services, then your data will be inconsistent. So pay attention, please, for that. Be careful with choosing the correct architecture style. And if you choose the microservice architecture style, if you want that the project will be successful, then think 100 times how you will divide the domains between services before you will start the implementation. Next, it is bounded context. This is actually what we're talking about. So the driving philosophy of microservice is the notation of boundary context. Each service models of a domain or workflow, but what is the correct boundaries of the domain? where it starts and where it ends. Thus, each service includes everything necessary to operate with the application, including classes, other subcomponents, and the database. So each should, you have to imagine maybe that, for example, after you already will divide and make the boundaries into your domain, try to imagine that you will get out one of the services. Will it work without it or not? What you will lose? The idea is to make as less communications as possible. Successful project has covered two things: high cohesion and low coupling. If you will follow this rule, then everything should be good. So what it means, high cohesion and low coupling? Low coupling between what? Between services, between the communication of the services. As less you will make, as less these services will be coupled, as less they will be in the, as more they will be independent, less dependent, as easily it will be works. In future, it means you will be able to replace one service by another. You can divide the work of the team. The developers will work independently mostly. It means that performance will be even much more higher because it will be less communication between services, so no need. So, and the performance inside of one of the services, it will be good. You can scale the service. This transaction will be supported in the boundary of the service, and so on and so on and so on. So this is one of the key and gold key to make these architecture styles successful or not. So architects struggle to find the correct granularity for services in microservices, and often make a mistake of making their services too small, which requires them to build communication links back between the services and to do useful work. So this is one of the mistakes, because a lot of maybe developers or designers, architects, they think that I mean designers, not the UI designers, but architecture designers. They think that if it names as microservices, so there is a keyword micro, it should be micro, but it's not micro. It doesn't mean that you have to make it as small as possible. Um, don't think that if it is named as microservices, then it for sure should be divided as small as possible. Not, it's not true. This is one of the key. This is one of the places where you can make a mistake. So microservices tries to avoid all kinds of coupling, including shared schemas and the database used as integration points. Next, it is API layer, which is also actual when we're talking about the microservice architecture. So most pictures of microservices include an API layer sitting between the consumers of the system, but it is optional. So pay attention for this, because maybe you see a lot of images on the internet, maybe you will pass some courses and so on, you will notice and that in most of the cases there is API layer. Pay attention that it can be, but it cannot also, like it's an option. While an API layer may be used to a variety of things, it should not be used as a mediator or orchestration tool. If the architects want to stay true to the underlying philosophy of this architecture, all interesting logic of this architecture should occur inside the bounded context. And putting orchestration or other logic in a mediator violates that rule. So it means that you have not think that this API layer, let me show you topology one more time, that this API layer is not the orchestration. It is not designed to make communication between services or like contain some logic that will know how this service should communicate with other services. Not at all, for sure. So the logic should be inside of the services. This API layer is optional. There shouldn't be any logic. They should be just only communication. So don't put any logic here. This is also one of the mistakes. Operational reuse. So given that microservice prefers duplication to coupling, how do architects handle the parts of architecture that really do benefit from coupling, such as operational concerns like monitoring, logging, circuit breakers, and so on? There is a pattern that is called sidecar. The sidecar pattern offers a solution to this problem, and here you can see how it can look like. For example, we have this is like a container, so we wrap our service into the container, and here is the separate database, and each service contains, for example, some part of the domain, but also you can see that there is a component which includes logging, monitoring, and so on. And this component is not like quite similar. This is the reusable component in other services. So it means that no need to implement for each service just the same part of code. Yes, we have to like how to say it. Will it be possible, for example, if you will put all of these things somewhere in one place, and then all of these services will communicate with this component? Yes, it will be possible. But remember that microservices prefer duplication to coupling. So if you will put somewhere in a separate place, then you will have coupling with this functionality. So it will be dependent. It will be easy to replace one service to another, or if you will, maybe there will be communication between domains. So if you will just replace one of logging, then it will affect all of the services, and you will be able just to remove one part and to do not re-implement all others. So in microservices, duplication is more preferable than coupling. So that's why you can see that each of the service has this component, but pay attention. This is wrapped also as a component. So it's not point like just only logins, monitoring, and so on. What is what is the point of it? That this component can be shared. So you can try another kind of technologies to work with this. Maybe it can be some jar files, or that can be included during the build stage. So it can be as a separate module that can be included during the building process, as an example. So what else? I think, yes, we have to, let's take a look to, just 1 second, maybe I will add something here. Yes, maybe, so sidecar, what it means, it's not present here. So you can put this component, it's one of the option, out of the service, but still in the container. And if you need to, for example, to make some communication, sometimes here you can see such as a service plane or something like this that will communicate with that will organize communication between these two components. That will be out of the service scope, but inside of the container. So this is also one of the preferable implementation of sidecar pattern. Oh, yes. Next, let's take a look to the front end part. So what it is. Microservices favors decoupling, which would ideally like mm, include the user interface as well as the backend concerns. So in fact, the original vision of for microservice included the user interface as a part of the bounded context. It is due to the principle of DDD. However, practically of the partitioning requires by web application or other external constraints make that goal difficult. That is why two styles of user interface commonly used or appear for microservice architecture. Here you can see one of them of these styles when we have a monolithic user interface that communicate with API layer. Another one approach, so it means that it is not always, yes, some of the project they build in this way, then we have monolithic user interface that communicate with API layer, and API layer consists separate blocks to communicate with each of the services. But like if we will follow DDD and we will try to truly microservice approach, then you can it is also possible to build frontend as a microphone frontend. So it means when each of them component will be also as a microservice, but it calls micro frontend, and each of them will be separated and connected with separate API layer and separate service. I cannot say that like for sure how the implementation of Google looks like, but as just assumption from the user perspective, you can also notice that, for example, you have Gmail, you have Google Maps, you have Drive, and they have like separate UI components with separate services, which is generally not dependent to each other so much. Next, it is communication. So in microservices, architects and developers struggle with appropriate granularity, as we already mentioned before, which affects both data isolation and communications. And finding the correct communication style help team keep services decoupled yet still coordinated is useful ways. So this is a point, okay, we are struggling about finding the right boundaries for granularity, but what about communication? How can we find the correct communication style to make this coordination still useful? So fundamentally, architects must decide on synchronous or asynchronous communication. This is one of the two options that currently technology can offer to choose. Synchronous communication requires a caller to wait for a response from that module that or service was called. Microservice architecture typically utilize protocol-aware this heterogeneous interoperability. What it means? Each of these keywords, it means like separate definition. Protocol-aware, it means that because microservices usually don't include the centralized integration hub to avoid operational coupling, each service should know how to call other service. So, and most of the implementation is used by the rest. Heterogeneous, it means that because microservices is a distributed architecture, each service may be written in a different technology stack. So it doesn't mean that yes, in mostly of the cases, if you will choose, for example, Java, then all microservice architecture will be in Java, but it doesn't, the rule means that this is a rule. One of the service can be written in Python, another one in Java, another one in C#, and so on. Interoperability. It describes service calling one another. So this is what it means. Another one point so that you have to think, and I will not tell you right now that here or always you should use synchronous communication or always you should use asynchronous communication. You can use both of them, and this depends from the design. In which cases you have to choose synchronous, in which cases asynchronous. Please pay attention previous architecture style, and we remember that sometimes maybe user is not expecting the performance, but it expect good reliability. So it means he expected quite fast answer for his request, and this is most important. And sometimes you can replace one of the quality attribute by maybe, but not replacing, but it means like maybe user has other expectations, and it will make feeling that the system is quite well performed, but under the hood it's not. It will just make all the things asynchronous, but at least he will make the feeling that everything works fast because he will make the response immediately, and in this other synchronous process you will proceed all his requests. And it also can be applied here. It depends how you will design the system. Another one key point that you have to pay attention when you choose the architecture style, it is, look, we will have a lot of services, right? How we will know? So we already understand that there will be communication. We will try to make this communication as less as possible, to make the service as less coupling as possible, to make the cohesion higher. But still there will be some communications. And it can be, let's say, it can be still some communication. How you will manage this? There are two options that can be applied. One of the option, it is choreography, and another one, orchestration. Choreography utilizes the same communication style as a broker event-driven architecture. In other words, no central coordinator exists in this architecture, respecting the bounded context philosophy. So it means there is no central place, there is no central service who knows in which moment we should execute this service or another one service, or so on. Each service know about what service he should execute and what will be the next step. So there is no centralized place. There is pros and cons from this approach. Maybe one of the benefits it is that it is more stable than if we will compare with orchestration. If one of the services will shut down, generally the system can proceed some part of the functionality. But for error handling, it will be much more hard to implement. From the other way, in orchestration option, so due to that microservice architecture don't include the global mediator like other service-oriented architecture, there shouldn't be. If an architect needs to coordinate across several services, they can create their own localized mediator. So this will be like a role of the mediator, but generally we are talking about the orchestration process. And this orchestrator will manage the process of executing one service by another, and so on. The disadvantage of this approach is that if something will happen with this service, then everything will break. But from the other side, if the error will happen in one of the service or inside of it, it will be much more easier to handle it and maybe to repeat, to remember the state, to forward the request to another service, and so on and so on. Transactions and transactions. So this is also one of the issues that you should expect when you start to work with this architectural style. So architects aspire to extreme decoupling in microservices, but then often encounter the problem of how to do transactional coordination across services. Just try to imagine how you will handle it, how you will do this, how you will implement it. Because the decoupling in the architecture encourages the same level of for the databases. So atomicity that was trivial in monolithic application becomes a problem in a distributed one, because transactions are going from where you take the instance of transaction. You are taking it from the connection instance, where you're taking the connection instance, connection to what? To the database. But here we have separate databases for each service. So it means separate service will have separate connection to the database, where you will execute the instance of transaction that will commit and roll back everything you put to the database. But here we'll have several services, and there will be communication between services, and each of the service has transactionality separate by each other. So how you will implement it? So building transaction across service boundaries violates the core decoupling principle of the microservice architecture. And the best advice for architects who want to do transaction across services, it's don't do it. So you should not, you can try to do, but it means something is wrong with your granularity. It's better to re-implement, to redesign your system, fix the granularity components instead. The result will be much more better than you will try to fix it. Yes, you can try, but you will still have some issues and it will never stop. So don't expect the transactionality between them. These modules, yes, you can find some articles, you can find some approaches, maybe even some tools that will try to do this, but it will bring you, just from my experience, it will bring you additional issues. The better choice, better decision, it is to fix granularity. Transaction boundaries is one of the common indicator of service granularity. So a popular distributed transactional pattern in microservice is the Saga pattern. If everything goes as planned, all the values in the service and their container database update synchronously. If an error condition, the mediator must ensure that no part of the transaction success if one part fails. So in this you can see it on the image. For example, if for example we have one of the requests to the service, another one, so it goes to for example here to credit card word, and we got the response with status 20, everything is okay. Then we try to make the request here, this service is failed, and so this service will be notified that this functionality was not implemented in a correct way. Then he should go to the previous credit card service and trigger the functionality to roll back everything that was made to make the data consistent between services. So because we have separate databases, and just only after that report to the user that something goes wrong. So generally it is, you can try to do it, but it will be quite complex. This is the simplest way, but let's imagine you will have not 2 services, you will have 20 services. What you will do? Will you remember all of these things on your functionality? Perhaps no. Not perhaps, but it is expected that it will be quite complex to do. Now let's try to finalize and understand what is the architecture characteristic for the microservices. Generally, you can notice from the first look that, whoa, it's quite well. There are almost 5 stars for all of them. So, for example, the high points of this architecture are scalability. Here it is, elasticity, yes, because you can scale your instances as much as you want. Elasticity, yes. Evolutionarity, yes. You can just replace one of the service by another, so it will be much more easily to evolutionate your approach. So some of the most scalable systems yet written have utilized this style to great success. Performance is often an issue in microservices. In a distributed architecture, like not just only microservices, but in microservices as well, generally in all distributed architectures. architectures must make many network calls to complete the work, which has high performance overhead, and they must invoke security checks to verify the tokens, so it will add the additional time between these calls and these communications. So the performance is not so well. You can notice that most of the disadvantages is cost and simplicity. It will be cost, it's not cheap to implement, and it is not simple to implement. But testability is quite good. There are separate modules, so for the test QA insurance team, it will be much more easily to test some part of isolated functionality. No need to test everything. Scalability is good. Modularity, everything is quite good. So this, if you will compare this architecture style with all others, it generally it has quite good marks. But is it a good choice for every approach? Not at all. If you hear from the stakeholders that we need something cheap and we want to implement it fast, like we don't have time and money and we need something fast, microservice architecture may be not the best choice to do. Will you deliver it? Maybe not. So that's all for this one, and next we'll be choosing the architecture style.